Welcome to Lubitech's Engineering, where we sketch out the things that keep the industrial world moving. Now, let's start.
You know, in just about any factory or on any construction site, there's a silent hero hard at work. It's the industrial gearbox. And its whole job is to take the raw, high speed from a motor and turn it into powerful, usable torque. That's the force that drives absolutely everything. They're essential, but honestly, they get overlooked, right up until the moment they fail. So, okay, let's dive into this and figure out how to keep these workhorses running smoothly.
So what is it that brings these powerhouses to a grinding halt? Well, this chart right here tells a really clear story. Just look at this. Bearing failures account for a whopping 50% of all breakdowns. 50! Then you add in gear wear and problems with lubrication, and suddenly you're looking at 95% of all failures. The key takeaway here? These things don't just happen out of the blue. And as we're about to see, they are very often preventable. And yeah, this quote from Oxmain just hammers the point home. More than half of all failures are from bearings. And the number one preventable issue is just plain old bad lubrication. So this isn't really about random freak accidents. It's about predictable wear and tear that we can totally get ahead of.
And you really want to get ahead of it. Because when a gearbox fails, we're not just talking about the price of a new part. No way. A single failure can shut down an entire production line. I mean, think about it. Missed deadlines, huge emergency repair bills, the ripple effects can easily push the total cost well into the six-figure range. The stakes are just incredibly high.
Okay, so how do we build reliability right from the very beginning? Well, it all starts with understanding the most fundamental concept of a gearbox, its ratio. This one little number is the key that unlocks absolutely everything about its performance, from its speed to its raw power.
So what exactly is the gearbox ratio? Put simply, it's how many times the input side has to turn for the output side to turn just once. It's this really fundamental trade-off, you know? You give up a lot of input speed to get low output speed. But the magic is that in return, you get this massive increase in torque, that all-important turning force. And this image makes it click, right? With a 20-to-1 ratio, that little input gear is going to spend a full 20 times just to get that big output gear to make one single rotation. You can totally see how that just kills the speed, but multiplies the heck out of the force it can put out. And that one choice, the ratio, it affects everything. We're talking output speed, output torque, how much load it can actually handle, and even the overall efficiency of the whole machine. Getting that ratio right from the start is absolutely the most important first step. So how in the world do you choose the right one? Well, it's not guesswork, thankfully. There's a really straightforward, step-by-step process you can follow to make sure you find that perfect balance of speed and torque for whatever you're doing. Let's walk through it. All right, here are the 4 key steps. First, you need to know your motor's speed and the final speed you need your machine to run at. Simple enough. Second, you do a little division. Input speed divided by output speed to find your perfect ratio. Third, and this is super important, you check the torque. You have to make sure the gearbox is rated to handle the load, plus what's called a service factor. Think of it as a safety buffer for all the real-world stress and strain. And finally, you just pick the closest standard ratio that a manufacturer actually makes. Okay, theory's great, but let's make this practical. Let's imagine we've got a conveyor belt, and it needs to run at a steady 70 RPM. Now we know our motor, a pretty standard one, runs at 1750 RPM. So boom, now we have our 2 key numbers, the speed we have and the speed we need. Now for the easy part. We just plug those numbers right into our formula. So 1750 on the input side, divided by the 70 we need on the output side, and that gives us 25. And there you have it. That tells us the perfect gearbox for this job is one with a 25-to-1 ratio. See, it's a simple calculation, but it's the absolute foundation for building a system you can rely on. But here's the thing. Even the most perfectly chosen gearbox is going to fail if you don't take care of it. And that brings us to the second, equally important piece of the puzzle, shifting from just fixing things when they break to proactively maintaining them. The whole idea is to turn those costly, chaotic surprises into planned, predictable fixes. Now, what's really cool is seeing the 2 main strategies side by side. On the one hand, you have preventive maintenance. That's all about time. Think of it like changing your car's oil every 6 months, whether it needs it or not. But on the other hand, you have predictive maintenance. This is all about data. It uses sensors to monitor the actual condition of the equipment and can spot a developing fault 4 to 8 weeks in advance. That's a game changer. And vibration analysis is a huge part of predictive maintenance. This chart shows the international standards for vibration levels. You can literally watch if your gearbox is humming along in the good range, or if it's starting to creep up toward unsatisfactory. A sudden jump, even if it's still technically acceptable, is a massive warning sign to go take a closer look before things get really bad. And hey, it's not all about high-tech sensors. There are simple warning signs you can see and hear. Any kind of weird new noise, like grinding or whining, that's bad. Obvious oil leaks, a temperature that's creeping up, or oil that looks milky because water got in, those are all huge red flags. Even an oil analysis that shows tiny metal particles can give you the earliest possible warning that something's wearing out inside. So, what's the big takeaway here? It's that true reliability isn't just one thing. It's not just about picking the right part, and it's not just about doing some maintenance. It's about fusing these two powerful ideas together into one smart strategy.
And this slide really says it all, doesn't it? It's a simple but incredibly powerful formula. You start with the correct selection, getting that ratio and torque right. Then you add on a proactive maintenance plan to catch problems before they become disasters. That simple equation, that is the key to reliability.
It really makes you think, doesn't it? These gearboxes are everywhere, doing this incredibly critical work, but they're basically invisible until they break. So it kind of leaves us with one last question to chew on. What's the most critical, invisible component in your world?
Thanks for watching. For more industrial insights, check out our other videos. Don't forget to like, share, and subscribe to Luvitex Engineering.